Hello everyone, I welcome you all in my channel The Logical Learning. Before I start, I request you to like it, share it and subscribe it. So today we will learn agglomerative hierarchical clustering. Basically this is bottom up approach. We start with bottom and move in the upward direction. So we start this algorithm. First, I will tell you the basic concepts of this algorithm. Its basic concepts are very simple. Only you can understand in two steps. So, first step, start by assuming each data point is its own cluster. Suppose there are n points A2, A3, and up to n points are there. So, initially, what we have to do? Initially, we will assume that every point is itself a cluster. That is, this one is one cluster, this is two cluster, three, and up to this is another cluster. So initially we have to assume every data point as its own cluster. Now what we have to do, merge the two closest clusters. Closest means we will calculate distance between every cluster, as we have assumed these are clusters. Okay, so closest means you will calculate distance. So for distance we can use simple Euclidean distance. For simple 2 point, suppose 2 points are x1 and x2, 2 points of x1 x2. For one dimensional, this distance given by modulus x1 minus x2. And suppose we have uh, data in two-dimensional space. 2 points are, say, c1 is point, say, x1 y1, and say c2 is the point x2 y2. So distance, this is given by under root x1 minus x2 square plus y1 minus y2 square. And for 3 and more dimension we can extend this formula. So this is known as Euclidean distance. Other distances are also there, Manhattan distance, and other distance functions are also there. These can be also utilized. Here I am going to use Euclidean distance. This is for one dimensional, this is for two dimensional, and or more than two you can extend this formula just like a z1 minus z2 square and so on. Okay, so initially simple 1 points are there, so we'll use this because only 1 point. Initially we have assumed that every single point is own cluster. It means only 1 point we have to calculate the distance in only 1 point. So we will use this formula, that is dx1 minus x2 modulus x1 minus x2 if the uh, points are in one dimensional space. Okay, so for one dimensional space, simple this formula we will use. As I told you, merge two closest means based on this distance. Suppose for example initially we have the minimum distance for a1 and a2. So first we'll merge these two clusters. Remaining clusters will remain as it is. So after first step, we will merge these two clusters. And we will repeat this exercise again and again, and merging will be done iteratively until we get only one cluster of all these endpoints. So that's why we are saying hierarchical and bottom to top approach. Means we are starting with all these endpoints, and finally we are moving in upward direction until all these points form only one cluster. So only all these points form one cluster. So that's why we are saying this is bottom to top approach. Now how can we write its algorithm? What are the steps? Simple step, as I told you, treat each data point as a separate cluster. So is step number one. Then calculate this distance matrix. Okay, now here different methods are there. I will tell you the different methods which we can use for computing this distance matrix. So distance between each pair of clusters, into closest clusters and merge them into new cluster. In this way we will have a set of new clusters. Then what we have to do, we have to update this distance matrix. Distance matrix means for the new set of clusters. After this step, we will have a new set of clusters. So then we have to calculate the distances for these new set of clusters, and we have to update the distance matrix. And we have to repeat these two steps 3 and 4 until we get one cluster. So in this way, finally you will get one cluster containing all the elements, or the numbers, or you can say items in the given set. Okay. Now to represent this, to show in a graphical way, we use dendrogram. Not to write determine, but you can say to represent. Use dendrogram to represent graphically. Okay. So dendrogram is used to represent this hierarchical clustering and the optimal number of clusters. From this diagram, you can easily view the different clusters and the hierarchy of these clusters. Now, as I told you, different methods are there. So, what are the different methods? First, single linkage. Single linkage, we use the minimum distance. For distance, as I told you, you can use Euclidean distance, Manhattan distance, or another distance. But this is a method, and method means what methodology we are using. For single linkage, minimum distance we will select. So this is the distance between Ci and Cj. For example, suppose you have two clusters, say for example 3 comma 5, this is one cluster, and in another cluster here the points are in one dimension. Just look at this. This is 3. Suppose for two dimensional data, point will be in two dimensional space, like 1 comma 1 comma 2, and say 3 comma 5. So this is for two dimensional space. In one dimensional space, these are the points simply written 3 comma 5. So these are the points in cluster 1. Say this is cluster 1, and say cluster 2 8 comma say 10. So these are the clusters. Okay. Now this is minimum single linkage DCI, the distance between two clusters C1 and C2. First we have to calculate dxy. X belongs to Ci, y belongs to Cj. Means first we have to calculate the distance between every point, every pair of point, in where first point is from C1, second point is from C2. That is to calculate dC1 comma C2, we have to calculate minimum of all these distances, that is 3 comma 8, 3 comma 10, and distance 5 comma 5 comma 8, and distance 5 comma 10. So first we have to calculate all these distances, then select the minimum of all these distances. This will give you dC1 C2. Clear? Now for, as I told you, for this calculation of this distance, you can use Euclidean distance, Manhattan distance. This is your choice. Generally I am preferring Euclidean distance. So next method, this method is complete linkage, maximum distance. Now in place of minimum, here we have to select the maximum. So it depends on which type of methodology you are using, whether you are using single linkage, whether you are using complete linkage. Every has its own advantage or disadvantage. This results in long chain like cluster. This compact and spherical clusters will be there. So it's your choice to use whether to single or whether to complete. So first one is single linkage, where we are using minimum distance. Second, complete, where we are using maximum distance. And next one is the average linkage, where we are calculating the average of all these distances. Average means, as I told you here, first we have to calculate the distance of all these, then average means this plus this plus this plus this divided by 4. So those 4 points are there, then we have to find the sum of all these distances, then divided by number of pairs. So this is average. So number of pairs divided by the sum of all these distances. So this is basically balance between single and complete linkage. Now another method, centroid linkage, in which what we can do, for example, suppose here we have one cluster, this 3 and 5. So we can find the centroid of this centroid. Simply we can calculate the mean of these 2 points. So how, suppose in place of 3, 4, 5 points are there, then we can calculate the mean of all these points, then we will get the centroid for C1. So this is simply mean of all this, mean of all these points, just like as here 3 plus 5 by 2. So this is centroid, centroid of cluster number 1, centroid of cluster number 1. So 8 by 2, this is, or you can say we have denoted, as I denoted by mu, so you can write it mu. For cluster C, better to write it with mu, mu1 equal to 4. Similarly mu2, we can calculate mu2 equal to 8 plus 10 by 2. So 18 by 2, this is 9. So there is a centroid of every center. So this method can also be used. Okay. So these are the different ways you can use for calculating distances. Now come to one example. We will solve this example. Data points are 3, 5, 8, 10, 15, 18 and 23. So what we have to do? First we have to assume that every point is a single cluster, means 1, 2, 3, 4, 5, 6, 7. So 7, initially 7 clusters are there. It means this is one cluster. This is second cluster, and 10, 8 is another cluster. Similarly 10 is another cluster, 15 another cluster, 18 and 23. Okay. Now we have to calculate the distance between every pair of between every clusters. Okay, so every pair of clusters. So here we can form a distance matrix like this. Here we can write 3, 5, 8, 10, 15, 18 and 23. So these are the same cluster. Distance obviously is 0. So distance between 3 and 5, I am using this formula, modulus x1 minus x2, because one dimensional data is there. So 3 minus 5, this is 2, this is 5 and this is 7, and you can calculate 12 and so on. This is, and 23, this is 20 and so on. You can calculate all these distances. After just making this matrix, I will show you this complete matrix. This is the complete matrix. Okay, I have calculated all these distances here. So these are the distances. Now what we have to do, look at this. For easy view, I have red colored the minimum distances. So these are, this is the minimum here. Now minimum appears here and here, so it means now 3 and 5 will be merged and 8 and 10 will be merged. So after this step, the new clusters will be 3, 5. This will form one cluster. Initially, as you initially look at this, this is it, 3 itself was a single cluster. Now we have merged, so this will form one cluster. Similarly 8, 10, this is another cluster, and the remaining 15, 18 and 23. So after this exercise, we have 1, 2, 3, 4, 5 clusters. Initially we had 7 clusters, now we have 5 clusters. The distance, the minimum distance in the first step was, this is 2. Just Remember this because this distance will be used to form dendrogram. Okay. Now look at this. These are the clusters, and again we have to form the distance matrix. It means now we will write here 3 comma 5, 8 comma 10, 15, 18, 23, and similarly here we'll write 3 comma 5, 8 comma 10, 15, 18, and 23. 23. This is 23. Okay. Now look at this. I am using single linkage. Single linkage method. Okay. It means I am calculating the minimum distance. This is 0. No need to calculate this distance because this is meaningless. Okay. Now where is 3 5 and this is 8 10, rather than, or if you are manually, if you are making a program, then automatically you need to calculate the distances for every pair of elements. But if manually, simply how can I do it, as I need to calculate the minimum distance. So here I will, the maximum point is 5 and the minimum point is 8. Obviously the minimum distance will be the difference between the highest point of this one and the lowest point of this one. So this difference between 5 and 8, this is 3. So if you write the program, then we need to calculate that all these distances, then we have to select the minimum distance. So here I have directly written this is 3. Similarly here 5 and this is 10 and so on. So here I show you, there is the matrix and these are the distances. So here this minimum distance is 3. Look at this. 3 appears here in 2 times. Okay. It means now these two clusters will be merged. These two clusters will be merged. So after this step, the new clusters will be 3 comma 5, 8 comma 10 and 15 comma 18, and finally 20, sorry, 23. So these are the clusters after this second steps. So these are the clusters. So again we will repeat the same process. We will form the distance matrix, and this is the distance matrix for these new clusters. So here look at this, the minimum distance is 5. So it means now all these clusters will be merged in one cluster. Now the process is terminated because finally we have only one cluster. One cluster means simply all these are in one cluster. So this is agglomerative hierarchical clustering. Now how can we show it using dendrogram? Look at this. What we have to do. Here we have to, in y-axis we have to write the distances. Okay. And in x-axis we have written all these points. If you simply, I tell you the process, how can you do it? This is x-axis, this is y-axis. So here simply you can write all these points is just like as 3, 5, 8, 10, 15, 18, say 23. So here distance is 1, 2, 3, 4, 5, 6. So if you go back initially from where we have started. Initially the distance was 2 and these two 3, 5 and 8, 10, these points are merged. Okay. So what we have to do? So 3, 5 distance is 2, it means 3, 5. You simply form a rectangle 3, 5 and the distance was 2 and 8, 10. So 3, 5, 8, 10 is 3, 5, 8, 10. So you can merge these two 3, 5, 8 and 10. So this here in y-axis this shows the distance. This length shows the distance of these two clusters which are merged together. So these were the cluster after first step. Now after this what we have done, okay, go back 3 5 8 10. Now distance was 3 and 3 5 8 10 and 15 18. 3 5 8 10 and 15 18. 3 5 8 10 and distance was 3. So these are merged and 15 and 18. Look at this. The distance is 3. So we have to increase up to this distance 3. And finally we have merged all these and distance was 5. So complete diagram is here. Look at this. Initially 3 5 8 10. Then in step this is, look at this is the first step up to this. This is the second step and this one is the third step. We have repeated this process up to third iteration only. In third iteration we got only one cluster. So this is the dendrogram. With the help of programming you can draw this dendrogram. So I hope that you got the concept of agglomerative hierarchical clustering. So thank you all.